Okay, so it starts here. Okay, I think yeah, in the lab you'll see a little guy like that. Okay, a little dot. So that would be the SA node. Okay. Oh yes, SA node. Okay. So we start at the SA node. Electrical signal will go through the next one to the atrioventricular node, the AV node. It goes there. Then it's going to go through the AV bundle, okay, right and left bundle branches, and up to these guys called the Purkinje's fibers, or Purkinje cells, okay, Purkinje fibers. Okay, so it goes like here at the SA node, across to here, across here, down the septum, and up to the Purkinje's. Okay, so if you look at the heart contraction, it will start contracting here first, squeeze the blood through here. Once this is filled, then all these will fire and squeeze the rest of the blood out to the system. Okay, so SA node. Depolarization, this is called a pacemaker, okay, because it starts right there. Okay, start at the SA node. Now then it will travel to this guy called the AV node. Okay, inferior portion of the interarticular septum above the tricuspid valve. So it's above the tricuspid valve, only electrically connected between the atrium and ventricle. Okay, cardiac fibroskeleton prevent conductive of electricity. Remember we saw that earlier. Impulses is a little bit delay here. Okay, the reasons is you squeeze this, you have to let the blood go through. All right, so that's why the heart doesn't really squeeze at the same time. Okay, this squeezes, let enough blood go through the ventricle, and then the signal will go through. This delay action potential allows the atrium to fully contract and push blood into the ventricle before the ventricles start depolarizing. Okay, so it's let all the blood go through here first before it starts squeezing. The next one will be AV bundle or bundle of His. Okay, call it bundle of His. These cells divide into 4 right and left bundles. Okay. Conductive cell move action potential to the respective ventricle. So there's going to be electrical going to the right side, electrical going to the left side, okay, along the septum. Then the last one will be Purkinje's fibers, responsible for the rest of the ventricular contraction. Again, we've seen this picture. Okay, this is where depolarization happened. Okay, repolarization, and then again getting ready to pump. This is a slow sodium leakage channel. Okay, we'll have spontaneous depolarization, so it's slower. Okay, we've seen all this. It opens channels for calcium and potassium. Okay. And don't have to worry about this one. Now, EKG, we have to study a little bit of EKG. Okay. EKG, if you look at this, okay, it's got different waves. Okay. Composite of all the action potential impulse generated by conductive nodes. So each one of these represent a part of the contraction in the heart. Okay, so of course this is normal. If you look at this, okay, we call this part right here the P wave, this big thing called a QRS complex, okay, and then the T wave. Here's where you can put the leads in. And we're going to study this, of course, extensively. So P wave, okay, the first one right there. P wave is atrial depolarization. So this is where the wave from the SA node through the atrium, okay, is 0.025 seconds after the P wave begin. Then the atrium will contract. Okay, so this little guy is telling us that the atria is about to contract. QRS complex, this big thing, is the ventricular depolarization. So you guys remember, just remember, you know, the ventricle is big. Okay, so now there's a big contraction of the ventricle and it squeezes. Okay, so that would be ventricular contraction. Okay, as depolarization reaches the R wave, which is the strongest there. Repolarization, T wave, ventricular repolarization, okay, which means the ventricle has stopped squeezing. Now it's time to relax. And the inability to respond to another AP contraction, another action potential. So right here, the ventricle cannot contract again. Okay. Atrial repolarization occur during ventricular repolarization. So this is where people get a little bit confused. So we remember this is where the atrium squeeze, right? After it squeeze, it has to relax. So when this squeeze, and then when the atrium squeeze, the ventricle will squeeze, but then the atrium need to repolarize to get ready to squeeze again. Okay, so this is where it happened. Atrial repolarization occur when the ventricular depolarize. Okay. Cardiac cycle, blood flows through the heart from the atrium. When the atrium contract, okay, atrial contraction is called systole. To ventricular relaxation is diastole. We see this in the systole and diastole is when you measure blood pressure, you use these terms. Okay, the number on top is systole. The number on the bottom is diastole. It measures how much, what is the pressure coming back or squeezing through. Okay. Atria are the primer pump. It fills the ventricle with blood. Ventricle are the power pump. It moves the blood through the body. Okay. Blood moves out of the chambers during contraction, which is called systole, and into the chamber during relaxation, diastole. Okay, let me say that again. So when your ventricles on the bottom, it pumps. Okay, that is your systole. So when you measure blood pressure, that is the top number. It's measuring how strong the blood is leaving your body. Right? After it squeezes, then it relaxes so blood will come back and fill up the heart. And there's also a pressure going into the heart. If it's too strong, it might damage the heart. And that pressure coming back when the heart relaxes is called diastole. So that's the bottom number of when you measure the blood pressure. Okay. Gases and liquid, blood from area of high pressure to low pressure, and pressure changes causes flow. When chamber are relaxed, this is low pressure, blood entering. Okay, the AV valve will open. Remember what the AV valve is? It's between the atrium and the ventricle. It will start filling up and then going into the ventricles. Okay. Here's what we should see. Depolarization trigger the atrial contraction, which is a systole, which increases pressure and pushes the blood into the ventricle. The action potential spread through the ventricle as they contract. Pressure increase and blood should be pushed into the arteries. Okay, so this is just a summary of what I just talked about. Now here, there are several of these diagrams. Okay, and they're all interconnected. They're all, okay, don't get them confused. Ventricle systole. What is ventricle systole? Ventricle is squeezing and the atrium is relaxing. Okay, so if we look at the picture here, okay, atrium is now relaxed, okay, during the atrial systole. So when the ventricle systole, when the ventricle squeezes, what do we have? We have the QRS complex. Okay, QRS complex, where is it? You find here. QRS complex right here. Ventricle will start contracting, squeezing all the blood out. Okay. This is the point at which the ventricle have the most volume, and it's called end diastolic volume. Okay. So we're talking about right here. When the ventricle has the most blood, and so if you divide the word, okay, don't get them confused. There's several of these that you might get confused. So N, so at the end of the diastolic volume, diastolic means relaxation. So at the end of relaxation, this is how much blood there is. So it's end diastolic volume. Okay. At this time, all 4 valves are closed because it hasn't squeezed yet. Ventricle systole continues. So now